Let's fully analyze the function f of x equals the natural logarithm of x over the square root of 1 minus x squared. We will find the domain, discontinuities, asymptotes, monotonicity, extrema, concavity, and the inflection point. Step 1. Domain. The natural logarithm requires x strictly greater than 0. The square root requires 1 minus x squared to be strictly positive, meaning the absolute value of x must be less than 1. Intersecting these two conditions, x must be in the open interval from 0 to 1. Step 2. Discontinuities. At x equals 0 from the right, the logarithm tends to negative infinity while the denominator approaches 1. So the limit is negative infinity. An infinite discontinuity. At x equals 1 from the left, both numerator and denominator vanish, but the limit equals 0 from below, a finite value at the right endpoint. Step 3. Asymptotes. Since the one-sided limit at 0 from the right is negative infinity, x equals 0 is the only vertical asymptote. There are no horizontal or oblique asymptotes because the domain is the bounded interval 0 to 1, and the function never approaches infinity at a finite limit point. Step 4. The first derivative. Writing f as a product of log x and 1 minus x squared to the minus 1/2. And applying the product rule, f prime equals 1 over x times the square root of 1 minus x squared, plus x log x over 1 minus x squared to the 3/2. Combining over the common denominator gives 1 minus x squared plus x squared log x, all divided by x times 1 minus x squared to the 3/2. The numerator can be rewritten as 1 minus x squared times 1 minus log x. Step 5. Monotonicity and extrema. To check the sign of f prime, we study the numerator g of x equals 1 minus w of x, where w of x equals x squared times 1 minus log x. The derivative of w is x times 1 minus 2 log x, which is positive on 0 to 1 since log x is negative there. Since w is increasing with limit 1 as x approaches 1 from the left, we have w of x strictly less than 1 throughout the interval. Therefore g is positive. F prime is positive everywhere on the domain, and f is strictly increasing. The infimum is negative infinity and the supremum is 0. There are no local maxima or minima. Step 6. Concavity and inflection. The second derivative equals n of x over x squared times 1 minus x squared to the power 5 halves. The denominator is positive on the domain, so the sign is governed by the numerator n of x, equal to 2x to the 4th plus x squared times log x, minus 3x to the 4th plus 4x squared minus 1. Setting n of x to 0 gives a unique root at approximately 0.7933. The function is concave down on 0 to x naught, and concave up on x naught to 1. The inflection point is approximately 0.7933, negative 0.3803. Here is the graph of f on the domain 0 to 1. The curve rises from negative infinity near x equals 0, illustrated by the dashed red vertical asymptote. The function is strictly increasing and approaches 0 from below as x approaches 1. The pink dot marks the inflection point at approximately x equals 0.7933, where concavity changes from downward to upward. Let's summarize all results. The domain is the open interval from 0 to 1. The only vertical asymptote is x equals 0. The limit at 0 from the right is negative infinity, and the limit at 1 from the left is 0 from below. The function is strictly increasing throughout its domain with no local extrema. It is concave down from 0 to approximately 0.7933. then concave up to 1. The inflection point is at approximately 0.7933, negative 0.3803. And that's the complete analysis of f of x equals the natural logarithm of x over the square root of 1 minus x squared. Follow for more calculus breakdowns. Thanks for watching. See you in the next one.